Welcome to this video on the chapter of laws of motion. So in this particular video we are going to cover the last question on the topic of pseudo forces. That is the question number 3. So this question would require the application of pseudo force along with the ideas of constraint relations. So let us see how we do this question. So basically we have a big mass capital M and you have a mass small m which is sliding on the surface of capital M. This whole block is connected to two pulleys, pulley number 1 and pulley number 2, and the system is drawn here. So let us just redraw the system quickly to understand what is happening. So we have a big mass M which is kept on a smooth surface. A smaller mass M is going to slide on top of the capital mass small m. So we have a pulley which is supporting the mass small m, and the other end of the string is connected to another pulley which is connected to the bigger mass capital M. This string is then finally joined to the ground via a hook. So the question is that if all the surfaces and the pulleys are smooth, then what is the individual acceleration of the mass capital M and the mass small m? So here I am shading the mass small m. We have to find what are the accelerations of this mass m and the shaded mass small m. So let us start analyzing by simple forces that what is going to be the rough motion of this whole system, and that is the approach we should take in solving some questions which require a little bit of thinking without before jumping into the equations of the laws of motion. So from the mass small m, we can say that as mass small m is sliding on a smooth surface, it is expected that mass small m is going to slip in downward direction, and as it is going to slip in downward direction, this particular length of the string, which is shaded by green color now, is going to extend, and its extension would come at cost of the string which we have labeled just now, that is this particular length of the string. So if I will label this string again, this particular string, it would go up in this part of the string, and then it would again come down and it would fill up this part of the string and cause the mass m to slide down. In addition to that, the mass m is experiencing a lot of forces. So let us assume that the whole system is moving in rightward direction with some acceleration a. So in the frame of reference of capital mass small m, the force acting on the smaller mass m is the tension force, the gravitational force mg, the normal reaction n, and the pseudo force acting in backward direction ma. Why the pseudo force backward? Because we have reversed the acceleration, and all this would cause an acceleration for small mass m in some downward direction. Now what would be the value of this acceleration of the mass small m? Now we have two ways to judge this judge what the value of a dash is going to be. First way is to think upon what we analyzed earlier. So we said that this green length of the string which we shaded, this particular length of the string is going to come eventually just on top of mass m. So the distance moved by this pulley or complete system capital M in the rightward direction should be same as the distance moved by small m with respect to mass capital M in downward direction. That is, the string which is available for small m to move in downward direction should be equal to the string which is removed from this part of the string. So that means that this acceleration a dash should be equal to the acceleration of the whole system a, as it is moving to the right with an acceleration a. So this a acceleration should come on mass m in downward direction. So let's say gravitational force mg, that is the downward force acting on the mass, minus tension should be equal to mass times acceleration of the mass m, which is a dash, equal to a. So this is the first equation we'll get. And now let us analyze this whole question as a complete system. So if we were to draw this complete system and then say that what is, and by complete system we mean that capital M and small m combined. So if we were to draw this system like this, and we would say, okay, what are the forces which are eventually acting on this system on a whole. So as a whole we would say this tension T is acting on this pulley in this way, and normal reaction exerted by capital M on small m in rightward direction, that is some n. Normal reaction exerted by small m on capital N, that is n. And let us talk about horizontal forces only. So normal reaction, tension, and these are the only forces. And upon the consideration that we are considering capital M plus small m combined as a system, normal reaction is an internal force and it is obviously cancelled out. So the only force which is remaining is the tension force. Additionally, we can think about some extra forces which I am going to label now, like the tension force acting on small m in upward direction, the tension force acting on the pulley in downward direction by the string. This tension to force T is indicated here. The tension force acting like this and the tension force acting like this. Now these are vertical forces, but still these forces are internal forces and will not affect the horizontal motion of the system, or rather any kind of motion at all, since these are internal forces. So we know that the whole system, small mass m included, must slide to the right with an acceleration a, and this is because of the fact that small mass m is sliding on this vertical face of capital M. So they have to move to the right with the same acceleration, that is, they are going to travel the same distance in rightward direction. Otherwise capital small m would either move ahead or move inside capital M, both of which are not possible. So tension, capital T tension, which is provided by the string, should be equal to the mass of the whole system, that is capital M plus small m, into the acceleration. So after we substitute the value of tension in this equation, we'll get mg minus capital M plus small m into acceleration a is equal to ma, and we'll get the value of acceleration equal to mg divided by capital M plus 2m. So this is the acceleration of the mass capital M, and we can find the acceleration of mass small m also. We know that mass small m is sliding in downward direction with an acceleration a and to the right with an acceleration a. The acceleration of the mass, smaller mass in ground frame. So for the smaller mass, acceleration in ground frame, let's write ground. So in ground frame, that acceleration is going to be mg upon capital M plus 2m. In downward direction, that is minus j cap, and in rightward direction, that is I cap. So this should be the complete acceleration of the system of the mass m. So thank you for joining this video and have a nice day.